Hello everyone, welcome to edupediaworld.com and thanks for watching Edupedia World videos. This is Vikas Patil. This is the second session of the chapter Motions of the Earth. In this session, we are going to explore another motion of Earth, the revolution. In this session, we are going to try and achieve the following objectives. Develop understanding about revolution. Develop understanding about the terms like orbit, plane of ecliptic, leap year, etc. Before we begin our exploration about the revolution of Earth, let us look at some of the common misconceptions that exist regarding the same. Earth's orbit is circular in shape. The distance between Earth and Sun remains constant throughout the year. The Earth completes one revolution in 365 days. All these are myths. Let us look at the facts. Apart from rotating on its axis, the Earth also moves around the Sun along a fixed path. This motion of the Earth is known as revolution. Both the motions of the Earth, rotation and revolution, happen simultaneously. Since the Earth takes 1 year to complete one revolution around the Sun, this motion is also known as the annual motion of Earth. The Earth revolves around the Sun in an elliptical orbit at a speed of 29.8 kilometers per second or about 1 lakh kilometers per hour. That's very fast. At this great speed also, it takes the Earth 365 days and 6 hours to complete one full revolution. This period of time is called a year. The Earth revolves around the Sun in an anti-clockwise direction, that is, from west to east. The total distance traveled by the Earth to complete one revolution around the Sun is about 940 million kilometers. The question that arises here is, we consider a year having 365 days strictly, whereas the actual time taken is 365 days and 6 hours. So what happens to these 6 hours every year? These extra 6 hours each year are added up to 24 hours or a day in 4 years. Thus, every 4th year we add an extra day to the year. Such a year, which has 366 days, is called a leap year. In any leap year, the month of February has 29 days instead of 28. The last leap year was 2012. The leap year occurs in every year that can be divided evenly by 4. Except the years that mark the end of the century. For example, the year 1500, although divisible by 4, is not a leap year because it marks the end of the century. Earth's orbit. The path along which Earth revolves around the Sun is known as orbit. Earth's orbit is not circular, but elliptical. This means that the distance between the Earth and the Sun does not remain the same throughout the year. The Earth is nearest to the Sun on or about 3rd January, and the distance between the Earth and the Sun is about 146 million kilometers. This position is called perihelion. Peri means near and helios means sun. The earth is farthest from the sun on or about 4th July. This distance between the earth and the sun is about 151 million kilometers. This position is called aphelion. Ap means away from and helios means sun. We know that the Earth's axis is inclined to its orbital plane, so the Earth is always slightly tilted in the same direction as it revolves around the Sun. This makes each of the northern and southern hemispheres tilt towards the Sun during half the year, 6 months, and away from the Sun for the next half year. Between 21st March and 23rd September, the North Pole remains tilted towards the Sun. Between 23rd September and 21st March, the North Pole is tilted away from the Sun while the South Pole is tilted towards the Sun. You must have noticed that days become longer in some seasons than night and vice versa. During March 21st and September 23rd, as the northern hemisphere is tilted towards the Sun, if you notice properly, both the lit and the dark areas near the equator are equal, which means that days and nights will be equal along the equator. As you go northwards, the length of the lit part is more than the dark part. It means days become longer and nights become shorter. A small region around the North Pole falls only in the lighted part, which means that places here will have daylight for 24 hours. The situation in the southern hemisphere is just the opposite. As we move away from the equator towards the South Pole, the lit portion becomes smaller and smaller while the dark portion becomes larger. This means that the length of the days becomes shorter while the length of the night becomes longer. After 6 months, the situation is exactly opposite. The figure shows the Earth when the southern hemisphere is inclined towards the Sun. This is during December. You can easily verify that places near the equator still have days and nights of equal duration, which tells us that places near the equator will always have days and nights of equal duration. But as we move towards the southern hemisphere, the lit portion becomes bigger and bigger, which suggests that the duration of day is getting longer. Places around the South Pole will be experiencing 24 hours of daylight. On the other hand, in the northern hemisphere, the days are shorter than the night, and places around the North Pole would be experiencing darkness for 24 hours. Due to the inclined axis of Earth, the circle of illumination shifts its position as the Earth revolves around the Sun. This means that the duration for day and night varies according to the Earth's position in the orbit. The winters have longer nights and the summers have longer days. When the northern hemisphere experiences longer nights, the southern hemisphere experiences longer days, and vice versa. The duration of day and night at the equator is almost the same throughout the year. As we move away from the equator, the difference in the duration of day and night increases. This was all for this session. In the next session, we will focus on the effects of revolution of Earth. Don't forget to watch. Thank you.